Okay, so I've discovered a bug that is affecting probably the majority of people running digital modes on Windows. It is a bug with a certain line of Texas Instruments audio interfaces. It is the PCM 2900 line. Anyone using a device with that USB audio interface chip on any version of Windows above Vista, so 7, 8, most likely 10, you're going to have this bug from my testing anyway, and you're going to have very poor quality receive on digital modes because of it. So I'm going to try to keep this quick, run you through it, show you how to reproduce the bug to see if you have it, and also a workaround that works pretty well if you keep your eye on it. And I've tested this with 6 separate people on 6 separate setups and radios. They all had the bug, and they all had about double the amount of decodes in JT65 after fixing this. And you'll just have a much cleaner signal overall. So let's jump into it. You need to open up your control panel here. Click on sound. Go to the recording tab. And it has to do with the level coming from your radio or your sound device. Now this affects the entire line of Texas Instruments PCM 2900 chips. So okay, what radios are those? Well, all ICOMs with a built-in USB audio interface use the PCM 2901. All Kenwoods with built-in USB interfaces use the PCM 2903B, and SignalLinks, the interface, they use a PCM 2904. These are all the same family of chips. They're all extremely similar, and this could very possibly affect more devices. I don't have a complete list of devices that use this line of chips. Rig Blasters might use them. Yaesus with built-in USB audio interfaces might use them. I haven't been able to test those yet, so I can't say for sure. If you have those devices, please stick with me and run through this test to see if you have it as well. And if you do, please leave a comment saying, I have this as well, here's my setup. So what the bug is when Windows first sees this device, or it comes out of Hibernate, or there's no applications using it, it will add about 60 dB of gain to your signal coming from your radio in the digital domain, which clips your signal, it distorts it, it's horrible. And you've probably, without even knowing what's going on, you've probably worked around it, even though your signal's still distorted. So you're saying, oh, well, the level here is fine, it's not clipping. What are you talking about? Well, that's because I've done what most people have done just for illustrative purposes and turned the level in Windows down, even though the waveform is still distorted, which I'll show later. So go to your radio interface here, click Properties, and we'll go to the Levels tab. Now this should be all the way up. This is what I found that I've worked with most people. This is what they've done to get around the bug without knowing it. They think, oh, I'm supposed to adjust my level so it's not clipping, so I need to turn this down all the way to here. Well, all this is an attenuation in the digital domain. You're just attenuating your signal, pushing it much closer to the noise floor, which is about minus 96 dB for 16-bit audio where you get quantization noise. That's bad. You want to set this to 100, and that's where it's doing nothing to your signal. So you're saying, oh, well, now we're getting distortion. That's horrible. Why would you make me do that? Well, this is why. This is because the bug I'm talking about is happening right now. I'm going to show you how to get rid of it. Go to the Advanced tab. Now to get rid of this bug, you have to toggle the channel count. That's the only thing I've been able to find that gets rid of it. So we'll switch to 2 channel. We'll hit apply. The bug is gone. We haven't changed levels. I have not changed levels on my radio. This is still at 100. There you go. That's the bug. It's gone now. Our audio is where it should be. I haven't had to add any attenuation in the digital domain. I haven't added any attenuation in the analog domain. This is our native signal coming in with no gain or attenuation at the level it should be. Now that signal is not distorted. It's a nice wave. I'll show you on an oscilloscope application a little later, but that's where you want it. So if you make that change and your level drops, you have this bug. So you can still go back to the channel count you were using. So I was using 1 channel. I'll go back to 1 channel, 48 kilohertz. Apply. Bug still won't come back. Just as a side note, I do recommend 48 kilohertz, not 44, 100, as these chips perform a little better at 48 kilohertz, a little better signal to noise ratio, not that you'll probably notice. And oddly, most digital programs I've used prefer the device to be at 48 kilohertz. I've done some controlled testing with tones and controlled noise, feeding it into WS-JTX. I got more decodes in a controlled environment at 48 kilohertz. So that's just a side note. So there, the bug is cleared. And you say, okay, well, that's it. Do I ever need to do that again? Well, yes, sadly, the bug seems to come back whenever the device goes idle, meaning there are no programs on your system using it. And this counts as a program using the device as it's reading the level from it and displaying it. So if I even do something as simple as switch to another tab where it's no longer reading from that device, the bug is back. Watch, I'll switch back. There you go. Bug is back. We'll toggle the channel count back to what we were using. Bug is cleared. So now if I open up my digital software, WS-JTX or whatever, that's going to open the device. That's going to use the device. Then you can close this off. It's not going to come back until the device goes totally idle again. But since discovering this bug, what I've done while running digital modes, I just leave this window up in the corner. That way I can visually see this bar get maxed out if the bug ever unexpectedly comes back, and I don't have to sit here wondering why my decodes have gone to crap and I'm not doing well in receive anymore. So I want to show you on an actual digital meter with some values on it what's happening here. So another way to easily get it to come back is just turn your radio off. I'm using an ICOM IC7200 with that built-in sound card there. So I'll turn it back. Windows enumerates the device, and that puts the bug on. So here's the bug. So here's a nice little free digital level meter. You want to go into options, make sure it's reading from your radio and not your computer mic. And I'll provide a link to this. It just provides, if you don't have any audio software on your computer, if you don't have a DAW you can use, this is a nice, free, tiny little program that allows you to set your levels well and actually have a decibel readout here. dB full scale is the measurement you want to use in the digital domain, which is what this is. So here with the bug, you can see we're totally clipped out. And yes, you can lower this slider in here and add attenuation. All you're doing is attenuating an already clipped and distorted waveform. It's going to be lower in volume, but it's still going to be a distorted waveform. So we'll see what it's with. We'll see what it's like after we clear the bug. Open that back up. And now you see we're not clipping at all. My radio is receiving a pretty strong signal here currently. So we're up here. The IC7200 and the 7100 do not have USB output level settings. They have USB input level settings, but no output level settings, which is honestly a good thing because from factory it's set exactly where it needs to be for proper levels. Receiving a strong signal here. We're still about 8 dB away from clipping, which is good. We have some headroom just in case we receive really strong signal or a stronger band, but we're still several dB away from the minus 96 dB noise floor of 16-bit audio. And if you download this program and use it to set your levels on your SignalLink or whatever, this is about what I recommend. Turn your AGC off because your signal will get much hotter. So turn that off. Make sure this is hovering around -8 or so. You just want some headroom, but you don't want it all the way down here. So that's what it should be at. And this is what it's at with the slider all the way up and the bug cleared. Now, I've seen people come up with some pretty funky radio settings and SignalLink settings to get around this bug. So I want to kind of walk you through how to properly set your levels real quick without going too much into gain staging and digital audio and all that. I just want to run you through this real quick and you'll have much better receive. By the way, I have people I've run this through with and people who I've gotten to clear this bug and work on digital modes. Their decodes on JT65 more than doubled. They had much better performance on RTTY and other modes, and that makes sense because you're feeding it a signal that's not distorted and clipped anymore. So just try this out and it should help you out a lot. But if you have a SignalLink, what you want to do is grab a program like this. Make sure you've cleared the bug. Keep this open and watch this. Make sure that's not clipping. Make sure the level slider in here is all the way up. That's just an attenuator, and you do not want to attenuate anything. And open an app like this, it gives you an actual readout and make sure it's reading from your radio there. And on your signal link, you want to turn up your receive knob until you're about right here. You know, you just want some headroom in case you get any strong signals all of a sudden, but you don't want to be way down here in the noise floor of your device. And I can't really get too much into per radio settings because I haven't checked many radios. On the people I worked with the Kenwood 480, what you want to do is set the menu, the USB output level menu in that all the way up, because that's an attenuator as well. It's just attenuating the signal going into the signal link. You don't want to do that. You want it putting out the native level signal into the signal link, and then adjust the signal link receive knob until this is about here. That way you're not adding attenuation in your Kenwood and then adding gain in your signal link. That's a very dirty process. You don't want to do that. So in the Kenwood 480, you want, I can't remember what menu item it is, but you want that output level turned to 9, I believe is the menu setting, and then adjust your signal link receive knob till about this. If you can't seem to get the right setting, or if you've turned the signal link receive knob all the way down and this is still maxed out, you have that bug and you need to clear it again. Okay, really quick, I wanted to show this on a scope so you can see the actual waveform. This is just a VST oscilloscope plugin running in my DAW I do my sound work in. So this is with the bug on. You can see our sine wave coming in here is now a square wave, because this is what digital clipping looks like. Your nice smooth sine wave has been pressed up into a square wave. So that's bad. That's why your decode performance is horrible and not what you were expecting. Now I want to show you why just adding attenuation to that already clipped signal in the digital domain, which is what you're doing by lowering that slider in Windows, that level slider. I want to show you why that does not fix the problem. So here's our distorted signal with the bug. I'm going to lower the level slider here in Windows, and you can see the amplitude of the signal is definitely going down, but it is still distorted. I'll freeze it here. You can see our sine wave is still clipped at the top here. You're still turning it in to a square wave, and that is bad. You cannot recover digitally clipped data in 16-bit space by just adding attenuation after the fact. I wish it was that easy, but it's not. So just lowering that slider in Windows will not solve this. You have to actually clear the bug adding the gain in the first place. So that's what it looks like when you just lower the slider. You can see it definitely lowers the amplitude there, but we're still clipping off the top of our sine wave here. Now I'm going to clear the bug and open this back up and show you what this is supposed to look like. So remember, this is what it looks like now. Looks like a bunch of square waves. Okay, so I've cleared the bug and I've opened my DAW back up here. I wish I could do it in real time leaving this up, but to clear the bug, you change the channel count, and any application using the device needs to be restarted. So I've cleared the bug, opened this back up. Haven't changed anything. All the level settings are the same. I've just cleared the bug, and now you can see we're actually seeing the sine wave that we should be seeing out of our radio. So I'll pause it here. You'll see we do not have digital clipping at the top of our waveform here. It's no longer a square. It's at the level we want. There is no distortion here, and that's what you want, and that's what's going to improve your digital decoding and your receive overall. It's worth noting this line of chips actually perform pretty well. I'd even say they're maybe slightly overkill for a radio application like this, where you're dealing with maybe a 6 kilohertz passband maximum and a relatively low signal to noise ratio, and a very low dynamic range you're feeding into the chip. So props to Kenwood, ICOM, and SignalLink for at least not trying to pinch pennies here. However, the main thing here is right on Texas Instruments supported operating environments for this chip line. It says pretty explicitly here, you can see that Windows 7 and newer are not listed. That would probably explain why this bug, I cannot reproduce it on Windows XP. I don't have Vista to try, but anything newer than that, this bug occurs. I'm going to try to contact Microsoft and see if there's anything they can do, but I doubt it, so I'm not sure. So that's about it. I just wanted to demonstrate this bug and give you guys a general outline of how to test to see if you have it and how to fix it. And I can guarantee you will get much better performance on digital modes. I've tested with 6 separate people, all with very different setups. They all reported a very big increase in decodes on JT and just a much cleaner signal overall, which makes sense because, you know, you're not adding about 60 dB of gain to it. So run it through, leave a comment, let me know if you had this bug and if this fix cleared it for you. Let me know if you have a different radio that was not listed in here and it still had that bug. Please let me know, and please get me the hardware ID for it. All you need to do for that, if you have a radio that's not listed here and it had this bug, right click on it, hit properties, hit properties again, go to details, then go to hardware ID in the drop down. Just copy and paste this longer one, paste it in the comments, tell me, you know, I have this radio, maybe it's a Yaesu, maybe you have a Rig Blaster, you know, it had this bug as well, here's the hardware ID. Send me that, then I'll know if that also is using the same family of Texas Instruments chips, or if maybe there's another line of chips that also has this bug, so that'll help me out a lot. Okay, so here in WSJTX, we have this slider over here, which is the digital gain for the audio input from your radio. Now midway, exactly on the middle notch is where you want it. That is 0, meaning it's not adding any gain and it's not adding any attenuation. Like I walked you through before, if you've set your signal link or whatever you're using up properly, you should be, you know, around here with strong signals. It'll come up to about -8. That's where you want it. But he is using a very odd meter here. He's trying to average the power over this passband here and push it out in a basically unitless meter here. If your audio is set correctly, that will be maxed out. He recommends setting it to about 30, which is very bad. To get it down there, you have to attenuate the crap out of your audio. This is actually how I discovered the bug. I'm doing some controlled tests with various JT software, feeding them pure JT tones mixed in with various forms of noise where I can control the signal to noise ratio, seeing which programs do better, seeing which audio settings do better. And that's how I discovered the bug. But anyway, I demonstrated very clearly that with your audio set as it should be here, so you're very far above the noise floor, with this slider in the middle, ignoring this, you will have far more decodes than pulling this down so it's reading about -30. I'll probably show that in another video. I'll probably be posting a separate video in the next few days showing these controlled tests between WSJTX and JT65HF, how they perform in different conditions, how to set your audio levels correctly, and how to get the most decodes. But I tried this with several people, and you can watch your decodes in a controlled environment disappear when you pull your audio level down to about 30, because to get this meter here to read 30 that he recommends in the manual, you have to pull your audio so it's hovering around -50 here in the digital domain, which is super low. You're missing out on about, 40 dB of dynamic range. You do not want to do that. So just a tip, leave this right in the middle, on the middle indent there. Ignore this meter. Use an actual meter with a known reference. dB full scale is what you want to use in the digital domain. Use that to set your audio levels, and do not use that. And just a side note, when you have your audio properly leveled coming into JT, he has his waterfall default settings kind of calibrated for the super low audio level he set his up with. You do not want that. So when you level your audio here properly, so it's hovering around -8, maybe a little higher with stronger signals, but away from the noise floor, the waterfall might look totally blanked out, way too strong. You want to set the 0 setting here, about -30 to -35. You can just play with the 0 setting until you get it looking how you want, so you can still see the background noise, but signals pop out pretty well. So just a tip. So that's all. If you can run through this and you reproduce the bug, let me know. If you can't reproduce the bug, let me know. And especially if you have a rig that's not listed here and you can reproduce this bug, please post the info below. It'll be a huge help to me in the bug report I'm going to try to make. So thanks so much.
Maybe we'll decide to get buried here.